Good evening and welcome. I told you I'd make a video for you so you guys can finish your homework. So let's get to it. First off, I will begin by finishing this problem right here. Given that these two things, these are our functions, f of x equals 6x, g of x equals x to the 3/4. So that means that f of x over g of x is going to equal 6x over x to the 3/4. Now, we could actually reduce that. The reason why is because when you're dividing, you're subtracting the exponent. So this actually turns into 6x to the 1 minus 3/4, right? Which is the same thing as 6x to the 1/4. A better way to actually see that is 6, no, not 6x, but more so 6 times the 4th root of x, right? And my domain here, I'm talking about my domain, since the root is even or whatever, the only values that will work in there are positive values. So our domain is no different from the other ones. Now we can talk about composite functions. All a composite function is a function inside of a function. So if a composite function is a function inside of a function, it's kind of this way. So say, for example, I give you a function. I'm going to call it h. I'm going to say h of x equals x plus, let's do a different one. I'll see h of x equals, say, 2x. Then that would mean that that would mean that h of 3 would just be 2 times 3, which is 6. It means something like h of 20 would just be 2 times 20, which is 40. If I just did h of, and I didn't put a number down, I put the letter a, h of a would just be 2 times a, which is 2a. Say if I did h of the word cow, that would just be 2 cow. So ultimately, say if I did h of, I don't know, x plus 2, it's the same thing as 2 times x plus 2, which is, as we recall, 2x plus 4, right? So say, for example, h of x was equal to 2x, and I want g of x to equal x plus 2. This is all hypothetical now. Then if I take one function and put in the other one, then you can see what happens. So with all of that, say if I'm doing h of g of x, right? If I'm doing h of g of x, you already know what g of x equals. If you know what g of x equals, then that means you can substitute it. In other words, you can make this h of x plus 2. And as seen down here, you already see what we get for h of x plus 2. So I just wanted to show you that part so we can get into composite functions. Remember, a composite function is a function inside of a function, meaning that pretty much I take an x. When I take an x, I can put it inside of a function, and my output is just whatever f of x is. With a composite function, we can take pretty much this entire thing right here, this entire thing, and put it into another function. And if we put into another function, this entire thing becomes g of f of x. That's all a composite function is. And ideally, it can go the same exact way. Say if I took an x, put it in here, then the function I have is g of x, and then I can take that entire function this entire function, put it in here, and I could end up with f of g of x. Either way, I'll actually show you some examples so this can help you. The f of x equal 2x minus 7 and g of x equal x squared plus 4. What is the value of g of f of 3? To be honest with you, you probably do not know how to do this whole thing right here. You probably don't know how to do this whole thing right here, but you do know how to do a piece of it. You can figure out, or you can find out a piece of it, and the small piece of it, actually, I don't want that. Let me rewind that. You do know how to do this small piece right here. Well, I'm sorry, you don't know how to do g of f of 3. But at least you can find out what f of 3 is, right? And in order to find out what f of 3 is, I should write that here. Why don't you just find f of 3 first? If you're trying to find f of 3 first, well, let's see what happens. You have f of 3 equals 2 times 3 minus 7, which is 6 minus 7, which is negative 1. So now, what we conclude, since f of 3 equals negative 1, I'll write that here. Since f of 3 equals negative 1, then g of f of 3 is equal to g of negative 1. And based on this is my function g right here, that's pretty much negative 1 squared plus 4. So 1 plus 4, which is equal to 5. So we can actually find what we need just taking a step. Basically find out the innermost function first, or go look at the innermost function first, and then we go from there. I'll give you another example. Say, for example, you have f of x equals 3x minus 8 and g of x equals 2x squared. Then what that means is if you have g of f of 5, I would find f of 5 first. And after I find out what f of 5 is, then I can go a little bit further, right? Let's see, f of 5 equals, since this is my function f of x right here, f of 5 is going to be 3 times 5 minus 8, 15 minus 8, 7. So that means that g of f of 5 is going to equal g of 7. And since this is my function, since this is my function g right here, then that means g of 7 is just going to be 2 times 7 squared, which is 2 times 49, which is just 98. F of g of 5 is going to be probably different in this case right here. Find, let's see, we're going to find g of 5 first. If I find g of 5 first, let's see, g of 5, I see what my function is. G of 5 is equal to 2 times 5 squared. Let's see, 25, this should be 50. So f of g of 5 is nothing but f of 50, which is equal to 3 times 50 minus 8. 150 minus 8, 142. So why don't you do these problems right here? Pause the movie, or pause the video. This ain't no movie. Pause the video, and why don't you find out what f of 5 is? And press play after you're finished or whatever, and see if we ended up with the same exact thing. So go ahead, pause the movie. Um, if you did f of 5, if I find f of 5, f of 5, let's see, you have 4. See, f of x equals 4x to the negative 1. This actually means the same exact thing as f of x equals 4 over x. Since x to the negative first equals 1 over x. So f of 5 is pretty much 4. Let me write it here. Let's see. F of 5 equals 4 over 5. So if that's the case, then really f of 5 is equal to f of 4 over 5. And if I'm just putting that in my function, that's really 4 over 4 over 5. Another way to actually look at that is I'm dividing. This is really 4 divided by 4/5. It's the same thing as 4 times 5 over 4. Cancel those both out. You get 5. So you can do the same idea goes with g of 5, but for the sake of the length of this video, whatever, I'll actually just go to my last thing. Given these two functions right here, are these the same functions? They are the same functions. F of x equals 4x to the negative first, and g of x equals 5x minus 2. I'm just going to find out what f of g of x is. First off, I know what g of x is. So if g of x equals 5x minus 2, then f of g of x equals f of 5x minus 2. And since that's the case, in f of x, it pretty much tells us that's what happens. So wherever you see an x, you just put 5x minus 2. So that means you're talking about 4 times 5x minus 2 to the negative first. Right? And since you have 5x minus 2 to the negative first, it's the same exact thing as 4 over 5x minus 2. Because remember, this is the same exact thing as saying f of x equals 4 over x. And if we're doing f of 5x minus 2, aren't you just going to add 4 over 5x minus 2? So now, if this is what our this is what our function is, your domain is pretty much every value of x that makes a true value or a real number or whatever once we put it inside of our function. So the only thing that's stopping us is if we get a 0 in our denominator. So in order to stop us from getting a 0 in our denominator, we need to know what, since it cannot be 0 or whatever, we can find out what x could be, or x has to be. So let's do it this way. We know that 5x cannot, all I did was add 2 on both sides. So this is pretty much telling me that x cannot equal 2/5. Basically, our domain is going to be from negative infinity to 2/5 union with 2/5 to infinity. So pretty much every number except 2/5 is included in that, right? That's pretty much f of g of x. Now, if I did g of f of x, it's not going to be the same. It's not going to be the same function, right? Since f of x is 4x to the negative first, then that means this is going to be g of 4x to the negative first, right? So that means that this is equal 5 times 4x to the negative first minus 2. In other words, 20x to the negative first minus 2. In other words, 20 over x minus 2. If you're looking at a problem like this, really, in this case, x could not equal 0. Why? Because if x equals 0, then this part won't work. So since that part won't work, our domain is going to be, our domain is pretty much going to be from negative infinity to 0, union with 0 to positive infinity. So, alright, I think I've showed you enough. Hopefully you'll be able to complete your homework. And y'all can let me know if you have any questions. Good night.